This is Chapter 16, Part 3 of Physics 102B homework, starting with number 83. Hold on, let me get some zoom here. Alright, starting with number 83. The problem says that it's dealing with paper, so we have the dielectric constants kappa of 3.7. and the maximum electric field of 16 megavolts per meter. Part A is asking what is the capacitance, so we just use the capacitance formula and plug in those numbers and get the answer of 8.868 picofarads. Question B is asking what is the charge, and so we, in Part A, found the capacitance multiplied by the given voltage in the problem, so you get 106 picocoulombs. And question C asks what is the maximum potential difference. So we have Vmax equals Emax for paper times the distance given in the problem, and we get an answer of 1920 volts. Problem number 85 asks about a capacitor and what is the distance between the parallel plates. So we use the equation for capacitance, but we solve for distance. Plug in the numbers with the information given, and you should get 12.7 micrometers. Question number 91. At the top of the screen, I've listed the given information for each capacitor, calling them capacitors 1, 2, and 3. So Part A asks which one has the greatest charge. And so what you need to do is use the equation Q equals CV, and you just multiply C times V and see which one is the biggest one. Now, I didn't bother to turn it into MKS units. You notice my units are microfarads times voltage, which gives units of microfarads volts. And so that really is microcoulombs. But as long as all we care about is a comparison between them, as long as they stay with the same units, it really doesn't matter what you call them. So between capacitors 1, 2, and 3, we get 3 microcoulombs, 10 microcoulombs, and 150 microcoulombs. So for Part A, the third capacitor is the winner. It has the most charge. Part B asks which one will store the most energy. So we use the equation potential energy equals 1/2 CV squared. Plug it in for each capacitor, and number 2 has the most energy. 500, I left it in the units of microfarads volts squared, but that really is microjoules. Part C then asks which one is the most cost effective in terms of energy per cost. So we can do this, we can figure this out in joules per dollar. And so we're looking for the most cost effective will be the one with the highest energy per dollar. So when we do the energy that we found in Part B divided by the cost of each capacitor, we get capacitor 1 is 1800 microjoules per dollar, and that's going to be the winner. Number 92. For the camera flash, Part A, power is just energy divided by time. So 5 joules divided by 10 to the negative 3 seconds, and that's 5 kilowatts. Part B asks for the capacitance. So you solve for capacitance 2U over V squared. Plug in those numbers and we get 250 microfarads. Part C asks about long term, what is the power? If it's using 5 joules every 10 seconds, then that would just be 5 joules divided by 10 seconds, or half a watt. And question 98 gives the current and the time. So what is the charge? Well, since current is charge divided by time, for part A we have charge is current times time. Plug in those numbers and you get 2 microcoulombs. Part B asks for the capacitance. So if Q equals CV, then C equals Q over V. We just solve for Q in part A, divide by the voltage of 4.5 volts, and we get 444 nanofarads. And that's the end of the chapter 16 homework.